morning, my dear students. So, this class we are going to continue the number system, chapter number 2. The last class we have discussed different types of number systems, right from decimal, binary, octal, and hexadecimal. Okay, and also we discussed the example also, right? Yes. So today we are going to continue the same chapter. So this is the tabular column. So this tabular column having all the 4 set of number system values. Okay, just see one by one. The first thing is decimal. This all numbers are decimal numbers, and this binary, and this is octal, and this is hexadecimal. So now we are going to identify the values from one number system to another number system. So if the number is 0 in decimal means you have to write the binary as 0, 0, 0, 0 like that. And suppose you have to write octal means you have to write 0, 0, 0 alone. And hexadecimal means again 0, 0, 0, 0. Okay. The next one, the number is 1 means you have to write 0, 0, 0, 1. So decimal value 1 means you have to write the same value as binary means you just write like that 0, 0, 0, 1. How here putting 1 here means the first value always, already told in the previous examples, in binary we have to use what? The first right hand side first value, what is the positional weight? That is what? 2 power 0, right? So the 2 power 0 means what is the value? 1. So now here the decimal value is 1 means the same positional weight you have to mention here. So where is it? 1, it's come the first positional value, that is 2 power 0. That's why we are putting the first right value is 1. Okay, even octal also same, and hexadecimal is also same like that. Okay, why? Because here 8 power 0, here 16 power 0. So all the first value is what? Obviously that is what? 1. So that's why all the 3 different types of number system, the first value is 1 here. Okay, the number 2 now, decimal value is 2. Now we are going to convert this decimal value into binary means how? The second number having 1. Why we are putting second number having 1 here? Why we are especially we are putting the number only for zeros and ones? Because these digits all are what? Binary numbers. So we have only zeros and 1 combination. So now the decimal value is 2. How it has come 0, 0, 1, 0? Because the next position weight is what? 2 power 1, right? So 2 power 1 means what? 2. So here what is the value? 2. So that's why the 2 positional value having, you are putting what? 1. So that's why 0, 0, 1, 0. So which value is appropriate related to the particular main value? That particular position you can enable. That time only 1 is come. Suppose that particular value is not available in the particular positional weight means you can put 0. Understood? Right. So this is the binary value 0, 0, 1, 0. And octal as usual, that is 2, 0, 0, 2. And here 0, 0, 0, 2. Because here 0 to 7 all are the same value. And here 0 to 9 all are the same value. That's why we are putting the same value here. But in binary, not like that. Okay. The next one, 3. Decimal value is 3. Now we are going to convert binary. How? We are putting 0, 0, 1, 1. How does it come 1, 1? Already we know. The first value is what? 1. The second value is 2 here. Right. So the first position always 1 means the main value is 1. The second position is 1 means the main value is 2. Now we are finding 3, right? So 2 plus 1, 3. So here 2 is presenting in the second number and 1 is present in the first number. So that's why both the number we are putting 1. Understood? So now this both the value is 1 means the first value having 1 and second value having 2. 2 plus 1, 3. So once you are putting decimal value 3 means you have to write the binary as 0, 0, 1, 1. And octal is 3 and next one is 4. 3 the same thing. The next number 4 in decimal, how is it possible? Number 4 we are going to write. So already we are putting 1 and 2 and 3 also you have find it. Now 4. So you have to check this decimal value is related to this binary series directly by the positional weight. So the first value is what? 1. The second value is 2. The next value is what? 4. Here putting 1. That means what? 4. How? this area especially, the positional weight is what? 2 power 2. Because the first value 2 power 0, the second value 2 power 1, then third value 2 power 2. 2 power 2 means what? 4. So that 4 value should be mentioned in the decimal, right? So this value is directly related to here in the sense that number you have to put as 1. Understood? So why we are putting 1 here? Because this positional weight is what? 2 power 2, that is 4. So these are matching together. That's why we are putting what? 1 here. And octal is as usual 4, and here also as usual 4, like that. Okay, so these are the ways you can write all the numbers, all the remaining numbers. It's like that, from binary and octal and hexadecimal, like that. Okay, yes, yeah, fine. So now we are going to the next topic. We are going to discuss about decimal to binary conversion. Decimal to binary conversion. So how the decimal number should be converted into binary? What is the method? Okay, so in number system we have two different types of method for converting this problem from decimal to binary. One is, the first method is repeated division by 2 method. Repeated division by 2 method. Okay, so we have theoretical information regarding about that. So once we are going to see the example, if you understand example well, in the sense after that you can read the informations, then you can understand well in a very easiest way. Okay, right. So directly goes to the example. What example? This is what? Decimal to binary conversion. We are following the method number 1. What is the method? Repeated division by 2 method. Don't forget. Okay. Now we are going to see the example. So these are the two different types of example. This is one example and this is another example. Okay. So now first we are going to see about this number 172, because when compared to this number is very high. So the steps are too many steps are come like that. So first we have to solve the first number, it's the smallest number, then after that we can solve this number. Okay, so first you can do the second sum, 172 base 10. So this is one of the decimal value. This decimal value we are going to convert as a binary. How is it possible? We are following the method number 1, that is what? Repeated division by 2 method. This is the repeated division by 2 method option. See that? Repeated division by 2. Got it? Right. Why we are following repeated division by 2? Because we are going to convert binary. So binary means the value is what? Base value is what? 2. So that's why. Okay. So right. As usual, in a earliest period in 8th standard, 7th standard or 9th standard, you have to studied about find the LCM, right? So can you find the LCM? That time you have to do some calculations, right? The same calculations you have to follow like that. So this side, first number 2, that is because we are following repeated division by 2 method. So you are putting 2 here, and this is the given value 172. And now you just divide it. So how many times? Here 2. Here take 2 digits, because the first digit is 1 here, but the main value is what? 2. So this is greater than this one, means you can't able to multiply or divide directly. Okay, so that time you can take the nearest number also. So now here 1, it is not multiplied or divided by 2. So that's why we are taking by the another number 17. So 7. So now it is what? 17. Now we are going to divide it. How many times? 8 times. 8 2s are 16, right? 1 2s are 2, 8 2s are 16. But the main value is what? 17. So put 8, 16. So 17 minus 16 balance 1. The 1 should be joined to the nearest number, that is what? 2. So 1, 2, combinedly telling about that 12, number 12. Okay, because the one balanced number is 1, so 1 is joined to here this 2. So now it's 12. How many times? 6 times. So 6 into 2, 12. So now it will be tallied. The remainder is what? 0. So putting remainder here, 0, don't forget. That's very, very important. Once the number should be solved completely, means the remainder should be 0. Sometimes it will be not completed, so that time we can put remainder is 1. Okay, so remainder you must mention here in the right hand side. Okay, right. So first step over. The next step 2 again. So the same number. The first number is 8. So 8 is greater than 2. So easily you can divide it. So how many times? 4 times. So 4 2s are 8. I just mentioned here 4 2s are 8. Then next 2 here 6. Yeah, it is possible to divide it. So 3 2s are 6. So it will be completely solved. So now the remainder is what? Once again 0. Right. Then once again we have to start 2 again. The first number 2 2s are 4. I put it. The next number 1 2s are 2. Balance 1. 1 2s are 2. We are putting here. So here 2 2s are 4. Putting 2. And here 1 2s are 2. That is 1. So the balance remainder value is what? 1. Because here 42. Here is 43. Right. So now balance is what? 1. That is the remainder. The next after that, the same number 2, done divided. How many times? 10 times. 10 2s are 20. Here 21. So remainder is 1. Once again. The next, again divided by 2. How many times? 5 times. 5 into 2, 10. Balance 0. The next, 2 times. 2 2s are 4. Balance 1. The next, 1. Here 2, here 2. So same thing, same number. 1 2s are 2. So balance 0. Then after that, we don't have any number divided by 2 because it is a 1, that is a last part. This is the ending part. To solve that, after 1 in the sense you can't able to divide the value by 2. That's why we are stopping here. So now we just write from this number onwards. From bottom to top you can take all the numbers. From bottom to, that's why we are putting the upside arrow mark. Okay, this upside arrow mark should be mentioned here for what purpose? To write the values from the bottom to the top. So write from 1 0 1 0 1 1 0 0. That is the answer of this decimal to binary conversion example. So you just write like that: 1 0 1 0 1 1 0 0 base 2. We are putting the base value 2 because we have converted one decimal to binary. So the final answer is what? It's a binary number. That's why I'm putting the index value. Sorry, not index value. The base value or radix value is what? Number 2. Okay. So the decimal number 172. This is the binary number of this 172 value. Clear? Right? So every time we are divided by 2 number. That's why we are following the method repeated division by 2 method. Understood? Yes. Though once finishing this class, you just write these example and you have to practice in your rough note or classroom note, whatever it is. And in your textbook also having some problems for converting decimal to binary. So you have to go through it and you can solve the problems. Okay, right. So here the topmost value, this is what that is what in this series, this is the LSB and this is the MSB. Why? Because the first value should be right here, right? Already told in the right hand side the first value is what? That is LSB. The left hand side the first value is what? That is what? MSB. So LSB now, what is the expansion? Least significant bit. MSB means most significant bit. So these are the two different expansion of this LSB and MSB. So where we should put the value in the number series, is it MSB or LSB? You can solve that. Okay, right. So this is another example. So now this example, if you are understood well in the sense, you can solve the same procedure here. Okay, the same procedure you have to apply here. Automatically you can get the answer like that. So this is a way you can convert one decimal number to binary. Okay, right. The next method. So first method, repeated division by 2 method is over. The next method is sum of powers of 2 method. Sum of powers of 2 method. So this, before we are going to discuss about this topic, we just go to refer the theoretical part of the first method. So see that what we are done already in the example part. Any decimal number is divided by 2, it will leave a remainder of 0 or 1. Yeah, of course. Repeated division by 2 method will leave a sequence of zeros and ones that become the binary equivalent of the decimal number. Suppose it is required to convert the decimal number n into binary form, dividing n by 2 in the decimal system. Here n in the sense given number, our question number. That question number value should be put here in the nth part and divided by 2, we will obtain a quotient that will be called as N1, and a remainder is called as, that will be called as R1, where R1 can have a value either 0 or 1. The process is repeated until the quotient becomes 0 or 1. Okay, so your quotient should be become whether it is 0 or 1 in the sense. Until that, you can do the calculation up to that. Okay, the process is repeated until the quotient becomes 0 or 1. Yeah, of course. Write the final answer starting from the final remainder value obtained to the first remainder value obtained. So final remainder value irundhu first remainder value varaikkum you can update the values from the bottom to top manner. So that is the procedure to solve the repeated division by 2 method, especially for converting the decimal number to binary. Okay, right. Yes, this is the method number 2, that is sum of powers of 2. It is also used to find the decimal number to binary conversion. The first point, a decimal number can be converted into binary number by adding up the powers of 2 and then adding bits as needed to obtain the total value of the number. Yes. Number 2, so this method you have to follow some important points. Option A, find the largest power of 2 that is smaller than or equal to 65. The given number is 65. Now we are going to find the largest power of 2. That is what? 1 square, 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4, etc. etc. Right? So this is useful to find the largest power of 2 that is smaller than or equal to 65. So here the given number is 65. So which one is the largest power of 2 regarding or equal to the particular value? Because here our question number is 65, right? Now we want to identify up to the 65, which one is the largest power value from the 2 option. 2 power 0, 2 power 1, 2 power 2. Which one is the largest power value? That is what? 2 power, which is the largest value? Sorry. Find the largest power of 2 method that is smaller than or equal to 65. This is a method you can find whether it is largest power of 2, which one is suitable for the given number. Here, the given number is 65, right? That is a question number. But we are going to identify, find the largest power of 2 value. So compare with this 65, which one is the largest power of 2 value? 64. Why it is come? That is what? 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4, 2 power 5, 2 power 6, 2 power 7, like that. But specifically, why you are choosing 64 means, after 64, what is another next power? That is what? 64 means it will be double to what? 128. So 128 is bigger than 65, right? So that's why we are not able to put there. So up to 65, the largest power value is 64. So now set the 64's bit to 1 and subtract 64 from the original number. Like that. 65 minus 64, that is what? Balance 1. Now 32 is greater than the remaining total. So therefore, set the 32 bit is what? 0. The next bit after the 64, the next bit is what? Before the bit is what? 32. It is 0. The next 16 will check, it is greater than remaining total, that is what? 1. So it is greater than that 1, so it is also 0. The next one is 8. It is also greater than the remaining total 1. So that's why we are setting 0. Then 4, it is also greater than the remaining total is 1. Then it will be 0. Then 2 is greater than the remaining total, therefore the 2's bit also it will be 0. Then finally, as the remaining value is equivalent to 1's bit, set it to 1. So at the very first, where will put the 1? At the 64th position, right? So right from there, the last position value only, we have the number is what? 1. So in between, all the remaining values having are allotted by 0. So the final answer is 1 0 0 0 0 1 base 2. So this is the example. This example only we have discussed previously. So this example, see that convert number 65. This number is converted into what? Binary. Yes, okay. The first step, the given number is what? 65. Yes, correct. The second step, equivalent or value less than power of 2 is 64. That means what? The value or the number should be equivalent or less than power of 2. Compare with the first number, that is the main number, that is what 65. Which one is the less power of this value? That is what 64. That is find the largest positional weight in the given number. Compare with the given number, it will be having some difference. That is what 65 minus 64. The balance is what 1. That is first step is over. The next step is 1 balance 1. 1 minus 1, that is what 0. Yeah, that is what the first value should be allotted for the first one. So 2 power 0, that is nothing but 1. So 1 minus 1, now it's what 0. So now what happened? What is the answer? You just see that the first value 64 having 1, so that's why you're putting 1 here. And second one where we are putting in the last 1th position here. Yes, this one the position. So that's why you are putting 1 also. So now 1 0 0 0 0 0 1. That is the answer for this conversion of decimal to binary. Understood? Yes. This is the another example of decimal to binary conversion. You just see that. I just clear the explanation. Here what is the given number? That is what 22. 22 is the given number, base 10. So this is one of the decimal number. Now we are going to convert this decimal number into binary. So this is a chart. See that the first thing, the largest power of 2 less than or equal to 222. First we have to identify it. You first find this number. The largest power of 2 less than or equal to 22. That means what? Less than or equal to 22 means what? Less than or equal to the given number. You have to identify it. So now this is a chart here. Which one is the largest power of 2 method? To compare with the given number, that is 16. Why means after 16, what is the power value? 32, right? So right from 1, you have to put 1, 2, here 4, here 8, here 16. How is it possible? That is what 2 power 0, 2 power 1, 2 power 2, 2 power 3, like that. This is the powers of 2 option, right? So now we are choosing the first 8-bit action. This is the 8-bit calculation, right? This is 8-bit calculation. That's what we have 8 different boxes. 1, 2, 3, 4, 5, 6, 7, 8. So this is 8-bit calculation. So first 8 values you can assign from 1 to what? 128. 1 to 128 you can assign like that. First number is 1, number 2, number 4, number 8, like that. This is the procedure. 2 power 0, 2 power 1, like that. Now the largest power of 2 less than or equal to 2 given number. So which is the largest power value? Compare with the given number. It will be might less than or equal to the same value. Alright. So which one is a suitable value? 16 only, not for 32, because 32 is greater than 22. Alright. So don't put like that. So you have to choose 16 alone. So we need a condition is what? One is equal or less than of given number 22. So 16 is less than 22. So we have to choose the first value. So in that position you can put 1. Okay. Now subtract 22 minus 16. How much? Remaining value 6. So this is another input value of the next step. So here now largest power of the same action. The largest power of 2 less than or equal to 6 now. That is the last main value, right? 6. So now you can find 6 or less than 6. So here we are selecting what? 4. Then after that 8. 8 is greater than 6. So don't choose that. So that's why you are selecting 4. So 4 having your put 1. So now 6 minus 4, that is what? 2. Alright. So already this 16 we are putting 1, the same thing, the previous step. Now the second step we are allotted one more option, that is what? 1. So 2, 1 is finished. Now the balance is what? 2. 6 minus 4, that is what? 2. So this is the main value of the next step. Now you can identify again the largest power of 2 less than or equal to the main value. So here in 2, the power value is also what? 2. So directly you have to put the 2th position where? Here. Here putting 1. The previous value 4 and 16 always are putting. Now in this step you can mention number 2 as 1. So that's all. 2 minus 2, 0. So finally we have a 0. So we are going to finishing the stage. So now at present 16 plus 4 plus 2. We have the split up of this 22 decimal value. So 16 having 1 already put, 4 having 1 already we put, and 2 having 1 already we mentioned. So 16, 4, 2. Wherever this number is there, that number, the corresponding position value is 1, so you have to mention as 1. Okay, this point, this value is enabled like that. You just assume wherever the 1 is here, automatically that corresponding power value should be enabled like that. So that's why 16, here 4, here 2. All these values having 1, the remaining all are 0. Then finally you have to write the answer like that. 0, 0, 0, 1, 0, 1, 1, 0. Right? So that is the answer I am mentioning here. But here mention only the 5-digit numbers. Why? From the right hand side 1, 2, 3, 4, 5. Because after that all are zeros, right? So no need to mention. If you are mentioning means that is also right answer. But no need to mention like that. So that's why here the 5 digits only they can write. But here the complete 8-bit protection. So that's what we are having. 8-bit form of the value of the given number is 22. Okay, so these are the steps you can follow to find the given number as decimal to binary conversion. This method name is what? What is that? Sum of powers of 2 method. So children, you just remind that if you want to convert one decimal into binary means we have a 2 different method. One is repeated division by 2 method. Another one is sum of powers of 2 method. So in this both method we have to follow only the number is 2 because we are going to convert binary alone. So that's why we are selecting 2. Okay? Yes? That's all. So thank you my dear students. Now the chapter number 2 number system is over. Why? Because from the government end the reduced syllabus is up to that 2.4.1 from this second chapter. Okay, so the second chapter we have so many topics, but the reduced syllabus or revised syllabus of yours means 2.4.1 up to that. That is decimal to binary conversion. Up to this topic, we have a topics, we have a syllabus for the second chapter. So that's why I finished the second chapter portion. Okay, so now we have completed totally chapter number 1 and chapter number 2. So you just go through it for whatever we taught already, and you can follow the textbook and you can refer it. Okay, then only you can get the informations. Okay, yes. Then next class we are going to see about chapter number 3. Okay, we will see that. Thank you all of you.